On problem 11, it says the Taylor series about x equals 0 for a certain function f converges to f of x for all x in the interval of convergence. They don't tell us what that is. That's okay. And then here's a formula to find the nth derivative at 0 for any n greater than or equal to 2. So you can use this when you start finding f double prime of 0 and anything beyond. The graph of f has a horizontal tangent line at x equals 0, and we're given f of 0 equals 6. Horizontal tangent line tells us that f prime of 0 is equal to 0. Because remember, that's where we've got some sort of a flat tangent line at a relative max or min. And then that ties into question A. Determine whether f has a relative max or min, or neither at 0, and justify your answer. So normally when we have this problem, we use first derivative test if we can. If we have an equation for f prime, we put the critical numbers on a number line, remember, and test. But we don't have an equation for f prime. So there's another way to determine if something has a max or a min, and this is our second derivative test. So if we know there's a critical number, so there's a horizontal tangent at x equals 0, and we can figure out the concavity at x equals 0, then that will tell us whether we have a relative min or relative max. So concavity is based off of the second derivative at 0. So let's see whether the second derivative is positive or negative. So we have a formula here. If we plug in 2, we get negative 1 to the third, so this is negative. And then 2 plus 1 is 3 factorial over 5 to the second, so 25. And 2 minus 1 squared is 1. So the second derivative at 0 is less than 0. And f prime of 0 equals 0. There's a horizontal tangent line. You could also just write this phrase. There's also a horizontal tangent line at 0. So that's the scenario right here. There is a relative max. I always need to sketch the picture to get this straight. Relative max at x equals 0. That is all that you need to say. You could explain, I think on the answer key I posted, that because f double prime of 0 is less than 0, that means f is concave down at x equals 0. Write these words out on the actual AP test. But this is not required on the scoring guidelines. Okay, write the third degree Taylor polynomial for f about 0. So we've got time here. I like to write out what this would be. So f of x is about equal to, I like to write out what it would be without the numbers first. So f of 0 plus f prime of 0 times x, because we're centered at 0, plus second derivative at 0, excuse me, times x squared over 2 factorial, plus we're going to third degree. So the third derivative at 0 times x to the third over 3 factorial. So f of x is approximately equal to this. And now we just have to sub in the numbers. So they gave us f of 0 at the beginning of the problem. F of 0 is 6. F prime of 0 is 0 because f has a horizontal tangent. Now you don't have to simplify these. I like to write it all out before I consider simplifying it anyway. So here we are. So plus 0x, that way I don't mess up my exponents. We already found the second derivative, right here. The second derivative formula is, so this is negative 3 factorial over 25. I'm just going to leave it like that. But remember that you also have times x squared over 2 factorial. So I don't want to forget about the 2 factorial, so that's why I like writing out this formula first. I have not yet found the third derivative. So let's see, if we plug in 3 into this, it's going to be positive, negative 1 to the fourth, so positive. And then 3 plus 1, so 4 factorial times x to the third over 5 to the third times 3 minus 1 So 3 minus 1 is 2 squared, so times 4. And remember, there's still a 3 factorial down here. Okay. And let's see, can we simplify this? Probably. Do I want to? What do we have to do? Let's see what we have to do in the next one. Yeah, find the radius of convergence of the Taylor series. So do I need to simplify this? No, probably not, because the radius of convergence is taking the nth term, which we're about to build with all of this, and using the ratio test. So first of all, let's figure out what our nth term is. So we're doing the limit. Well, no, sorry. I'm going to write out the general term. So what is that general term? That's going to be the nth derivative at 0 times x to the n over n factorial. And the nth derivative at 0 has this formula like this. And we multiply that by x to the n over n factorial. So yeah, we can clean this up a little bit before we toss it into the ratio test. Like n factorial cancels with n plus 1 factorial to leave you with just n plus 1. And that doesn't do a lot of work for me, but it simplifies things a little bit. So if I want to find the radius of convergence, I'm going to perform the ratio test. So the limit as n approaches infinity of the absolute value, so I don't care about the alternating piece, n plus 2, because we're doing the n plus 1th term, so n plus 2 times x to the n plus 1 over 5 to the n plus 1 times n plus 1 minus 1, so n squared, times the nth term, so 5 to the n, times the reciprocal of the nth term, 5 to the n minus 1 squared over n plus 1 times x to the n. Keep your limit notation because you haven't performed a limit if all you're doing is simplifying, which you should simplify, rewrite this, once you cancel stuff out. So none of the n's polynomial expressions will cancel. So I'm just going to collect those. I've got an n plus 2, an n minus 1 squared. And then in the denominator, I've got n squared and n plus 1. And then for the x's, we have an x left on top and a 5 left in the denominator. So now I can take the limit. So when we plug in infinity for the n's, this is a rational expression. It's degree 3 on the top and degree 3 on the bottom. So that limit goes to 1. We're left with the absolute value of x over 5. And this series would converge by the ratio test if we keep the absolute value of x over 5 less than 1. And that translates to x over 5 falling between 1 and negative 1. We don't have to test endpoints on this one because this question just asked for the radius of convergence. So the radius of convergence is right here. The radius is equal to 5. Whether or not we test the endpoints does not change the fact that the radius, the distance from the center to the end of the interval, whether the end is included or not, that distance is 5. Let's see. And that's all that we had to do for number 11. So that problem was, I think, a little bit shorter. It's always kind of nice when they give you a formula for a derivative like that.